In this video, I'll give you a quick idea about the superimpose of waves. When I say this term, what does this mean? That means how do you add the two waves? So let's say, for example, you have one wave here, the green one, and you have another wave too. So in this case, particularly this case, the wavelength and amplitude of both waves are exactly the same. What is the wavelength here? So in this case, the wavelength is from this low to another low here. This one is called the wavelength. Okay, that's called the one wavelength here. And this one is called amplitude. The maximum displacement from this mean position is the amplitude. This one is called amplitude. Okay. And this one, from this point to this point, we call as a wavelength, or from this point to this point, we call as a one wavelength here. So now I have two waves, and I'm going to choose particular conditions here, and the term we're going to use is constructive interference and destructive interference. Constructive interference here. And destructive interference. So, for example, if I have these two waves can be added together. Let's say, for example, here, perfectly like this. When the two waves exactly overlaps on each other, just like this case, then you're going to add this peak and this peak together. What will happen if I add them together? The resultant wave would be bigger. So that's what exactly here is. It is bigger. Okay, this one is bigger. And this kind of interference, or this kind of addition of the two waves, or this kind of superposition of two waves is called constructive interference. When the two waves perfectly match each other, that means the peak and peak lies exactly at the same position, the low and low lie exactly at the same position, then the resulting wave will be the addition, will multiply, will double in fact, and this wave we call as a constructive interference. Now what happens the other case here? So if I just took another example here, for the example, if the wave is exactly like this, then if I add the two waves together, for example, let's call this is -1 and this is +1. If I add them together, what number I will get? I'll get 0. This is already 0. If I add 0 and 0, what the number I will get? I'll get 0. If I add this number and this number, what the number I will get? I will get the 0, because one is positive, this is positive, and this is negative. I will get 0. At any point, if I add these two numbers together, it doesn't matter where, I'm getting the 0. So the wave cancels out each other in this case, perfectly cancels out each other. And this kind of wave we call as a destructive interference. So you see here, so these two waves lies in such a way that the peak of one wave lies to the negative peak of the other. For example, this peak here, and that's the low here, or negative peak, lies perfectly to each other, and as a result they perfectly cancel each other, and that kind of wave we call as a destructive interference. Okay, and there is another situation when this wave, let's say for example, is not perfectly aligned or not perfectly destructive, somewhere in between. And the somewhere in between could be this way here, this is somewhere in between, this is also somewhere in between. So between this maximum, or between constructive and destructive interference, then the wave you will get is just like, the beat, you may get a beat. So you get something between the maximum and the minimum. So what is the superposition? The superposition is the resultant displacement of two waves, or we call as a vector addition of the individual displacement of the two waves at one particular point. that we call as a superposition of two waves. Let me write down better. Superposition of two waves. Superposition. Position of two waves. So this is it from this video. If you have any question, any comments, write down in the comment section below, and do not forget to like, share and subscribe the channel. Thank you very much.